Welcome to another episode of Field Phone Ops. Today we're going to look at the U.S. Air Force's Signal Terminating Unit STU-5. So go ahead and sit back, and I hope you learned something. Now we're going to take a look at the STU-5. I'm going to explain a little bit about what they were and how they were used and some of the problems we use them to overcome. First thing we're going to have to do is we're going to have to jump back in the Wayback Machine and go back into the 1980s and 1990s. Systems that we used for our SATCOM, triple circuit scatter, line of sight, microwave were all four-wire carrier systems, they're called. The only way we could physically get a signal into them was via four-wire connections on them. And this worked good. There was four-wire digital phones and four-wire analog phones. So the problem was not all the phones and stuff you wanted to connect would work with this four-wire system. Now, this diagram, it would do four-wire point-to-point signals that used a tone that would pass through, but it would not work with any kind of dial-up phone. If you wanted to do a four-wire or what's called PSTN or normal dial phone, would not work. Would not work with two-wire commercial phone lines at all, like you used to have in your house. Same with faxes and modems, and it didn't allow field phones, ring-down phones to be used. So you couldn't hook two TA312s up over a satellite link and make them work. So this caused issues. So the solution was to come up with what was called the STU-5. And the STU-5 is basically a signal terminating unit. And what it allowed us to do is convert and change things and modify the signals so they could go into the SATCOM or through the SATCOM and come out the other side and be used. So one of the things we do is here's your four-wire PSTN or plain old public service switch telephone network, or PABX. It was a four-wire circuit. It would not work directly with this. It had to go through a STU-5. The STU-5 would then see it go off hook, send a tone through the satellite to the other STU-5, which would see the tone and connect it to the switchboard. This STU-5 also connected and converted to two-wire, so it would go into the switchboard. Same with the phone call. If a phone call came in, it would go to this STU-5, see the ring. It'd send tones over the satellite link to this STU-5 that would then convert it to something that these phones could understand as far as the ringing would go. The same is true with traditional two-wire telephone circuits. They wouldn't work. So what you do is you put two STU-5s in, and this STU-5 on one end basically connected, the phone would connect to, and then the other one connect to the switchboard, and then it would basically allow you to make just normal phone calls over a satellite link, which is a big deal. We use that quite a bit for just getting regular old, actually getting access to DSN, which is like military watts, to get phone calls in and out of a remote site. And the final thing was to do ring down circuits. Basically, that would be a 312. You pick this 312, you don't have to crank it. You pick it up. This STU-5 sees it go off hook. It sends a signal to this STU-5, which in turn rings this phone. So it's automatic ring back and forth, and that was used quite a bit. Now, the STU-5s themselves were interesting. They had a drop side and a line side. The drop side is where you connected your phone. So it was could either be two-wire or four-wire, common battery, local battery. You could connect field phones to it, commercial phones, PABX or PSTN switchboards, or faxes and modems. Then the other side was the line side. The line side is what actually connected to the carrier system. So whether you're going to be used SATCOM, triple scatter, line of sight microwave, or a long haul cable system, it was four-wire only, and that's how it connected. It had some things on the front. It had the switch right here was used to adjust the frequency that was sent back and forth to signal things going on. And then you had these green LED lights on here. These lights would come on and off as different things occurred. If the phone was set in four-wire mode, we'll talk about this later, the STU was set up as a four-wire STU, this light would always be on. It was an indicator to you that would go on, that it was set in four-wire mode. And then these green lights would come on and off depending on what the other side was doing. So if a phone went off hook, you'd usually see this come on because it'd be sending a tone to the other side. When the other side got the tone and sent another tone back, this would come on. So there's always lights going on and off. That's how you could tell if it worked. Then these little screw pots right here allowed us to set the levels. The idea was to get the levels set so they're just right on the brink of where they need to be. Otherwise, if you get too much signal tone on them, it interferes with the voice call, and it also makes them sound bad. And the same thing, if you get too weak of a signal, you can't understand the audio. So it was very important to get them set right. I don't have the equipment to set them, so I'm just having to sort of listen to it and adjust it by hand. So they work okay, but when we had a transmission test set we could use, we could really get them tuned, and they sounded really good. It was surprising. Okay, next. This is an example of how we'd set them up, the diagram we'd use. This is a remoted 2-wire phone line to a commercial phone. So basically, we would connect one STU-5 that was configured for a 2-wire phone and plug it into the switchboard line. Then the line side would go across to your signal carrier, whether it's SATCOM or Tropo or whatever. Then your remote side is where you'd hook your phone up to and be set for 2-wire. And as soon as you pick this phone up, this STU-5 right here saw it go off hook, sent a tone to this STU-5, which told it, hey, we're off hook, we need dial tone. This STU-5 converted it from 4-wire to 2-wire, sent it to the switchboard. The switchboard provided dial tone. You got dial tone on this phone, and you could dial and make phone calls back and forth. Same thing with the ring, back and forth. Like I said, it was one of those you had to get a set just perfect to get it to work good. The other thing you had to get used to is if you're working on a satellite link with delay, you had about a half second of delay on the line. So when you would pick the phone up and it would go all the way through, it took about a half second for those signals to get all the way over the satellite to the switchboard and for the switchboard to send something back to you. So you had to get used to when you talk to somebody, you'd have to wait because it took a while for your signal to travel to them and then get their response. So we used to call that a learning curve for SATCOM. Next was, this was a common one. And this is one I talked about. All of our radar control shelters with our weapons controller set had consoles built into them. They didn't have individual phones. They had consoles that they plugged their headset into, and they had phone lines and all kinds of stuff. Well, the only dial phone line they had built into the console was a 4-wire dial phone line. So in order for them to talk through their console on just a regular old 2-wire phone, we had to use STU-5s. And the reason they did this is because everything that went through the console was recorded. So when they're doing missions, they recorded everything going on so they could record what was said on phone calls when they were talking to command post or whoever that was going on. They recorded the phone call. And it worked the same way. It just was, this was set for 4-wire on this side, and this side was set as 2-wire. And like I said, a phone call would go all the way through and back and forth. We use this a lot. We use a lot of this without a satellite link, just sitting on the ground with wire between them so they could get access to PABX or PSTN phone lines from inside the shelters using their shelter comm. This was another one. We had a lot of point-to-point circuits for different purposes, and there's always traffic flowing back and forth. You had Air Defense Command and Control Network, you had Track Supervision Network, Interface Control Network, Voice Product Net, and these were all point-to-point things where information was being passed. And one of the things we had, once again, the controllers had to use the phone in their console. They didn't have a 312, so we'd take and set their 4-wire phone to act as a point-to-point, use a STU-5, and we can convert it to make it ring as a 312. We use that a lot. Then this was used a lot because on site when we were up and going and running, they had a lot of stuff going, especially between the operation shelters where the controllers were working at and the command post area where they'd have to pass mission results, air refueling results, everything going on was constantly being passed back and forth. And the command post, we either use a commercial phone or a 312, and then inside the OM, we could configure there to set up to do a 2-wire circuit, and it was all automatic ring down, so you didn't have to do any cranking. So the guys in the radar shelter would hit that line to call the command post, and it would just ring this 312 or commercial phone, depending on how many stuff we had going on with the commercial phones. And they could pass data back and forth. It's, like I said, results of engagements or air refuelings or whatever they're doing. And this worked the same way. If you picked up this commercial phone, it would automatically ring inside the OM. So this is just a few of the things we did. The actual manual for setting them up has a what's called what's a chart in the back, and there are 43 different ways you can set these STU-5s up, and it gives you an example of how to set them up. Tells you all the settings to use and get it lined up so it works back and forth. So you can do a lot of things. I've actually used these to key radios over a satellite link using what's called E&M signaling, which is another thing they'll do. This is how we actually had them set up and we would use them. We had ones that were mounted in the equipment rack right here. They're mounted inside here. They appeared over here on patch base. So you could use patch cords to move them around. And then we just patched whatever signal we needed. These are standalone STU-5s up here. These are just extra ones we'd set up here for spares. I also had some of these that were mounted, just 4 of them in this rack were mounted in a transit case. I had 2 transit cases so we could set them somewhere and not have to worry about taking this whole shelter out to do work. And this is how I have them set up in my basement right now. I've got 8 of them. I've got 5 right here with the labels on them that are actually working. I had to go through and do some work on them. The fuse holders were shot, so I had to put new fuse holders in. I was in the process of doing. Then these ones right here have broken. These have to replace the fuse holders, and they have some broken wires in them. So eventually I want to get them up and running. And I want to get a shelf built to put them on so I can get them off the table. But this is how we'd set them up, and we'd label them, the remote end, the local end. So when you were looking at the manual, you knew what was going on. If you had to troubleshoot a circuit, you knew which end you had to look at. And that's pretty much it. Next, we're going to go ahead and get out, and I've got some stuff hooked up on the table. We'll go ahead and make some calls and show you how they worked. Okay, I actually got the STU-5s in the other room and the phone's out here, so we don't have so much clutter. We're going to demonstrate how the STU perform different tasks. And this is one of my STU-5s right here. This one needs some tender loving care. It's broken fuse holder on the front. I need to replace that. There's some broken wires inside. But it gives you an idea what the front of it looks like with the test points and the adjustment screw pots. Then on the back is the binding post you actually connect the wires at. And then the unit itself will actually slide out of this enclosure like this. And that's it. And each one of these circuit boards along this side, all of them inside there, have jumpers in them. And you move the jumpers around according to what you want the STU-5 to do. And the actual technical order's got a spot in the back that lists 44 different configurations you can use the STU for, and it tells you how to set all your settings, what levels to set, and all that stuff. So that's basically how you set them up. The first one we're going to look at is an actual a 4-wire dial-up telephone circuit. This phone is a 4-wire phone. It will not connect to a normal PABX or 2-wire phone circuit unless you use STU-5s, and that's what it did. So the first thing we do is I'll call it. So here we go. That's what the ring sounds like. I'll go ahead and pick it up. Test 1, 2. Test 1, 2, 3, 3, 2, 1. That's how it sounds. And we'll go the other way with it. We're going to call this. I have a cordless phone hooked to my PABX so I can make calls. We'll call now, and that's 26. There it is. That's one standard use of a STU-5 right there. The next one is we talked about point-to-point circuits, and this is a 4-wire phone and a regular old TA312. These will not normally talk to each other. But by using a single STU-5 in the correct configuration, we can set it up so that whenever you pick the 341 up, it'll automatically ring the 312. Test 1, 2. Test 1, 2, 3, 3, 2, 1. Test 1, 2, 3, 3, 2, 1. And that's what it sounds like. It's an automatic ring down circuit. We'll do it the other way. And it'll actually ring, I think, of 2 or 3 seconds before it'll stop. Or there's an option you can actually set it so it's a continuous ring, or you can set it up so on the 312 you actually have to crank it to make the phone call go through. That's, like I said, that's all the options you have. And the final one is actually an interesting one. If you pick up this commercial phone, it rings that field phone. Test 1, 2, 3, 3, 2, 1. Test 1, 2, 3, 3, 2, 1. Yeah, there's a little bit of a noise on it. I don't have the equipment to actually precisely set the STU-5s up, so it's a little bit noisy. Now I'll go the other way. Does the same thing. It's roughly a 2-second ring. It's also possible to take and remove this EE8 and put a second commercial phone, so two commercial phones will call each other, or to remove the commercial phone itself and put a field phone in. My next project's going to be is I'm going to go ahead and go through and see if all my local battery field phones will work like this in this configuration right here. There'll be something else to just try and see if it'll work. I hope you enjoyed it. If anybody has any questions, please let me know. Thanks for watching.